Hi everyone! In this video, I will show you how to find the moment of inertia of an I-beam and program it in Excel, so you never have to do it ever again. And I will show you two different methods. The first one, I will add the moment of inertia of the blue rectangles and the pink rectangle. In the method number two, I will have the moment of inertia of the full outside shape, and I will remove the two rectangles. Why I show you this second method too? Because this second method does not require the theorem of parallaxes, so that could be good to have it too. But let's start with the first one. I will move that down so you don't get to look at this one, but that will be later. Number one, okay, let's say I have high beam with a central element that is, let's say, 2 inches and 12 inches, and let's say the shape number 2. The base is maybe 14, and this one is maybe 3. Okay, they're usually the same. I just put different numbers so we don't mix them up. We can check after that some example that we found online or in books and see if it's correct. Let's get the area, because we need the area at the end there for the theorem of parallaxes for the blue rectangles, and also sometimes for some, for example, normal stress, you may need the area. So let's get it. The area of the pink shape is the base time the 8. The area of the blue shape is the base time the 8. And the total area will be the pink rectangle plus 2 times the blue rectangle. Don't miss that. So that will be 108 inches square. We need the distance between the centroid of the general shape and the centroid of each element, each rectangle. So if we are strategic there, we put the y, the referential y equals 0 at the center because that's our centroid. We don't need to find the centroid because it's perfectly symmetrical. Okay. If H2 and H2 there were different, that would not be the case. But this is perfectly symmetric, so we know that the y will be in the center there, like in the middle of the H1. But what we need is a distance from this centroid of the I-beam and the centroid of the rectangle for the theorem of parallaxes. For the shape number 1, that will be just 0. Okay, we can just enter 0 because the rectangle, the center of the rectangle, centroid of the rectangle is there. For this one, that will be the distance from here to here. That will be the the H1 divided by 2 plus the H2 divided by 2. And this is the same distance for both of them. We don't need to find the total or anything. We don't need that. Now we need to find the I at the centroid. So the I of the blue rectangle from that axis and the I of the blue rectangle there from this axis. Okay. So this is always 1 divided by 12 times the base times the H cube, and we can drag that formula. And we can see that the one that increased the most, the like the that stopped the rotation about that axis for the moment of inertia, the red one has a very larger moment of inertia there because it's higher and the H is cube. But those shape number 2, the blue rectangle, will be we will add the term parallaxes because it's far away from the centroid. So check that. Let's do now the formula of the thermal parallaxes. It's equal to the I that we found plus the distance square time the area. Enter. So this one is the same because the distance is the same. And this one, 2,394. See how increasing the offset from the centroid increase the mass moment of inertia by a moment of inertia by a lot. That's the area. And now I found the total, so that will be the I from the pink rectangle plus 2 times the blue rectangle. And the units are, let me write them there, inches. Oops, inches fourth, so we don't forget them. I will move them to the right. So this is the mass moment of inertia R shape. Now, let's check the second method. And the area will be inches square. So I like to have my units close so I don't forget. and all the base and age should be in inches. I can write you can write at the unit there. That will be nice too. So let's see for the second method. I will move it up. Oops. What I will use is I want to find the base and the age of the full part. So the base of the big one will be the B2. So equal the B2 from this one upstairs. That will be the 14. Here we go. And the 8, that will be the H1 plus 2 H2. So the H1 plus 2 times H2. Okay, so this is my full rectangle there. Okay, and the shape number 2, the base will be that distance. Okay, so that will be B2 minus B1 and divide by 2 because it's just one side. So equal B2 minus B1, and I need to add parentheses to that, divide by 2. Okay, and the 8, it will be just H1 equal H1. Here we go. So now I can find the area equal this one time this one. Same thing, I can drag it. But now this time the area equal 252, so the total there minus the 2 inside. So equal this area minus 2 times this one. And hopefully we have 108 like this one. Yes, we do. So that's perfect. Let's now find the centroid, and what is great is that if the centroid is there, the centroid of this large rectangle and those two rectangles is at the same place. So we don't need to do the theorem of parallax axis, we don't need to do the d square. Let's just do the 112, 1 divided by 12, oops, 1 divided by 12 time b time h cube. That's it. Let's drag this one. And now it's equal to this one minus 2 times this one. And here we go. We have the moment of inertia that is the same. If they are not the same, we are in trouble, of the I beam. Use the method that you want. If you have your formula, your Excel made and ready to go, you have it. It's perfect. Make sure it works. Check with a few I beam that you find online. Just change your. I like to do something. I really like to highlight what I can change, so I can change those values, and that's it. That's the only thing that you can change. Okay. Everything else, all the other cells will update, and you can put those two cells the same color because they should be the same, and you can put those two cells the same color. Oh, I didn't pick the nicest color ever, but here we go. They should be the same. If not, there's a mistake somewhere. So here we go. I hope that helped. Let me show you everything together. We can have everything together there. And it's a nice little Excel to keep in mind. Hope that helps. Bye bye.